All right, hello. So tonight I'm going to talk about my development environment at work and how I built it. Before I do though, I'd like to hear a bit about all of your developer environments. So I'd just like to hear the hands up. Who actually uses Boxen to set up their environment? Ooh, just a few, okay. What about Vagrant? Who uses Vagrant? Okay. Who uses Babushka? Ooh, interesting. Okay, and who does all of their development entirely inside of Docker? Okay. So some of you didn't raise your hands at all, and that's fine. For some of you, though, I think you probably should be using some form of automated environment setup. So who's doing that with some kind of script? Okay. All right, well, if you didn't raise your hand, that's fine. For simple projects with few people, actually environments don't matter that much. For a whole bunch of gem development and for a basic project, it's easy enough to just say use Ruby 2.1 or greater, or just have a README, it's fine. Even in those cases, sometimes though, who here hasn't had to help a non-developer or maybe even just a non-Ruby developer set up a project once in a while? Because even these so-called simple tasks can get complicated. When things do get complicated, it becomes important to be consistent. And in order to get consistency in developer setup, you need to have tooling. So I started my current workplace 4 years ago, and I'd like to tell you a bit about my first day and getting the development environment set up there. So I arrived at the office bright and early, meet my new team. I was given a shiny new MacBook, which is fantastic, and I settled in to set it up. A few hours to install everything, I was told. This is the first time I'd ever touched a Mac, let alone use one for development, so there was some stuff to learn. Apart from figuring out where the start button had gone, I also had to read through a whole bunch of wiki documents to get my environment set up. Installing the basic programs went fine, but we also used Boxen to configure most of our environment. And to say our Boxen environment was a flaming pile of junk is a massive understatement. It ended up taking me 2 days of debugging and countless hards inside of home to get my system into the Boxen code to fix. And it didn't just affect me, it affected everyone at the company. I must have lost days and days to our setup. At this point, it might surprise you to learn I didn't actually blame Boxen for that, and I still don't blame Boxen. More, I blame our usage of the tool. Still, it was pretty clear that it didn't suit our needs as a company, so a couple of people worked on getting us all onto Vagrant. We used a lot of Chef in production at the time, and we had some pretty serious bugs that came out of discrepancies between our development environment and production. Using Vagrant, we could populate that and set it up using Chef, and then we just sprinkle some if statements here or there whenever we needed something specific for our dev environment. Hopefully we could eliminate some of those bugs. You might not know, but Vagrant is just a command line tool and some easy stuff to use around a virtual machine, running VMware in our case. It was a massive improvement over our Boxen system. It cut our reliance on Homebrew, which was fantastic, but it did have problems of its own. We have a massive monolithic Rails app. Pretty big one, actually. It was slow to boot and run on development machines, and virtualizing it only made it worse. As a happy Vim user, I just SSH'd into the Vagrant box and did all my editing there. But for graphical editor users, editing was slow as crap. With these virtual machine systems, you've basically got two options. You can host your code on the virtual machine and make editing terrible, or you can host your code on the Mac and make your applications run incredibly slowly. We were in a bit of a bind. Another problem also got worse over time. Those little if statements we added to the production cookbooks started to multiply, as I'm sure you all predicted. And one branch or the other didn't get as much testing as it should. We didn't break production very often due to this, but we broke development environments a lot, as often as once a week. And when that happened, usually it required a couple of hours of debugging and fixing, and then everyone had to rebuild their Vagrant environments from scratch, which could take up to half a day. This wasn't helped by our occasional users only running Vagrant up every couple of weeks, and they got so far behind everyone else that the normal upgrade process didn't work for them. They had to go through that half-day setup process every time they wanted to use the core product. So that later problem could be solved with more discipline, but other problems couldn't. For us, VMware turned out to be really, really flaky, especially after a Mac resumed from sleep. VMware would just not bring the virtual machine back up and Vagrant would hang. So after a few years of using Vagrant, we decided it was time to find a new system. We'd switched to Docker in production and CI, and containers seemed like a safe bet at this point. But Docker for Mac wasn't even a thing when we first looked into this, and when Docker for Mac was released, it was built on top of VMware. We couldn't run far enough away. We decided that Rails should run on the Mac to avoid those file sharing issues I mentioned with Vagrant. This means the return of Homebrew. Luckily though, it had stabilized massively over the last few years, and I hadn't had to do a hard reset inside of Homebrew in quite a long time. So this means switching our environments back to the Mac means that our dev environment is once again divergent from production. But the state of our chef files meant that we were pretty divergent anyway, and all of our ops teams had spent a lot of effort making those differences not matter anymore. So, running apps on the Mac means we have dependencies. Each app has certain libraries and databases and language versions that it needs to run. And we need a way for each project to specify that, because we can't simply just install everything everyone uses on everyone's laptop. I'm pretty sure I won't ever have to use the R or Java bindings that we provide, for example. So we built a Ruby tool called Dev to manage these dependencies for us. To use the tool, we have a shortcut to clone Git repos. It doesn't do anything special. It just does a clone and a CD from GitHub. And then you run then you run dev up. This makes sure all the dependencies are installed and services like databases are running. When you run dev up, it looks like something like this. And this is the case where everything's already been installed for you. It's just starting up servers. In addition to Java and R, we obviously also provide Ruby support, otherwise it wouldn't be here. But also projects in Python, Go, JavaScript, Objective-C, Lua, Swift, and a bunch of others can also be used with dev, and they all work exactly the same way. All use exactly the same commands. Configuration is done in a dev.yaml file in the project directory. Here's the one for the dev project itself. So it's a declarative format, it's YAML. Stuff under up is run whenever a user runs dev up. And the command section provides some custom stuff. We also add certain commands like dev server that will always run a server. The way we implemented this is we originally didn't implement any commands, and then we looked at what the first projects were doing in their command section and then just made those default for everyone. So that way we built consensus amongst the whole company. For example, we never saw the need to have a dev style command. We would just always run rubocop directly. But it turned out to be really useful when we wanted to add shell check and everyone else was running rubocop and a JavaScript linter, for example. Now you can go into any project, run dev style, and it'll always work. So you can't actually see it in this dev.yaml file, but our dev project is actually dependency free at runtime. That means we run it without Ruby gems. These ones here are just the development dependencies. We do this partly for simplicity, but the primary reason is speed. We have a shell hook that runs on every command prompt to make sure that your Ruby version, Node version, all that kind of junk is correct. And people are really precious about their prompt speed. Our shell hook takes about 20 milliseconds to run. But if we didn't use the --exclude -gems flag that you can give to Ruby, that time would double to 45 seconds. And that's consistent. That dev up command I showed you before takes about 100 milliseconds just to check that everything is installed. But it would go up to about 125 milliseconds just by not excluding Ruby gems. Note that that's not actually using any gems at all. That's without anything. Once you start adding more gems, the time starts increasing and increasing and increasing. Here's the dev.yaml again for the dev project. The up section contains an entry for each task that must be done. In this case, it says that Homebrew must be installed and that Homebrew should install those packages. Here's the code we wrote to install Homebrew. The grey code you can pretty much ignore, that's boring, but have a look at the syntax and the structure of the code. We have a dep or dependency at the top level and it declares the task. We have a met block and that's called first and checks whether the dependency is met. If that returns true, we don't bother doing anything. It's fine, we can move on. If it returns false though, we have to run the meet block and that will install whatever it needs to be installed. Then we run the met block again to make sure that it actually succeeded. Look, this syntax is super elegant and to be frank, it's one of my more brilliant ideas. Only kidding, only kidding. I actually nicked it from Ben Hoskin's Babushka project. Speaking of which, I'm sure those of you who have used Babushka, which is very few people, I'm surprised. I'm sure those of you who use it are wondering why we didn't just use that instead of writing our own, because it's a very similar project that solves a lot of similar problems. I personally use Babushka all the time for my personal stuff like grabbing my dot files and compiling Vim. But there are a few reasons why we didn't think it was appropriate to use it ourselves. I'd be lying if I said one of those reasons wasn't not invented here syndrome, but we did actually have some major advantages in doing it ourselves. It's important to have control over the user experience. Shell integration is really awesome, and we also make sure that all of the Ruby, Node, and whatever other language version switches are working properly. We can also support default and custom commands. Babushka allows people to run external code from GitHub, and we didn't want that feature. I've been burned before with open source deps from both Babushka and Chef due to their flakiness, and not having that feature means we have really good oversight over what code we're actually executing. Babushka isn't necessarily designed for speed, and Dev is, so that's a definitely consideration. But Babushka is better for a whole bunch of other reasons. Most of the deps people actually share are great and save you a lot of time in writing them. Babushka's helpers, such as the tooling around file management and Git repos, is far superior to devs if you're writing your own deps. And it's also independent of a given project. So it's actually better for things like fetching those dot files that I talked about or installing programs that only I use. And this is something I still use it for. Let's get back to how we install Homebrew. This is another dep in the same file. And again, the grey stuff isn't very interesting. But what we do, we had to add this because bug got shipped in Homebrew last year, and it meant that everyone had to go into their user local and do a git reset hard. And we've fixed that for them. No one had to bother with the problem. And that's fine, it's great. We saved everyone a lot of hassle, but what I also did was introduce a maintenance issue. This code could safely be removed back in December, and I didn't discover it until I was researching for this talk. Actually, I think we're probably missing an abstraction here. There are loads of these temporary issues that come up. There are always things that only affect a couple of users or are only relevant for a month or two, or are just really, really rare. Mixing those temporary concerns with the default install scripts I've learned is actually a really bad idea. Like I said, we're missing an abstraction, a list of hotfixes, which would have mandatory and prominent deprecation warnings. And I think that would help this problem and keep our codebase small. So that mostly covers how we actually run applications. All of the other stuff we install is basically just more deps just like that. They're all very simple. But there is a large category of dependencies that we found don't actually work well on Mac. Some of these don't work on Mac. They're not supported. Things like Zookeeper and Kafka because of Zookeeper, and also stuff that we've written that only works on Linux. Other things fall into the category of data stores that have permanent state, and we found that those don't really work all that well on the Mac either, because of if you have to have multiple different versions of Postgres installed, that gets somewhat difficult. So what we do is we run all of that kind of thing in Docker-like containers. So I said before that we consider VMware not to be fit for our purpose. We tested out VirtualBox as well, and that wasn't good either. Worse than VMware, in fact. So what were we to do? Thankfully, we were developing this thing right at about the time OS X Yosemite was released. And as part of that release, Apple finally released the hypervisor framework. And that's the magic that allows access to the system calls which Docker and all of the other container systems need to run. We're also lucky that Michael Steele had just ported over Beehive to OS X in the form of Xhive, which is a library that sits on top of that framework and makes it a lot easier to build containerized systems. So because Docker for Mac wasn't a thing yet, we decided to build our own Docker-esque container system based on Xhive. We called it Railgun. This is how a project specifies that it needs Railgun. All of that stuff is auto-generated when you add a dev.yaml file or you start a new project. You just delete the services that you don't want. We register that IP with a central server so there's never any conflicts, and that really simplifies the way we do networking. In fact, I think Railgun's networking model is better than Docker's because we just make basic assumptions about there always being an Nginx in the container, and that just makes everything really easy. The other thing Railgun is good at is that we do binary diffs of image updates, and that means even in Australia, when I'm hitting EC2 and S3 over in the States, I still get super fast image updates. That said, Railgun's only better in those two ways. In every other way, Docker is better. So I don't really recommend using it. Thankfully, Docker Mac is now a thing. It's been out for a while. It's nice and stable. So that's definitely worth using. Neither Dev nor Railgun are open source. I've already said that Railgun is not worth open sourcing, but we get a lot of questions about open sourcing Dev. A few people internally also want to open source it, but I've been opposed to that idea for a while, and I want to explain why. On all of our work laptops, we've got a very homogeneous setup. It's likely that a bug affecting one of us will affect all of the people in the company, or at least a significant portion. So that's a really time-valuable problem to fix for us. With more diverse users, I have more diverse problems, which require more and more fixes, which lead to more complexity and more maintenance for the code base. We have the luxury of just being able to tell people to upgrade to Mac OS X Sierra, and that solves a lot of problems with outdated packages and things like that. Dev is also really tightly coupled to that networking model I talked about earlier, and it's actually a lot of work to convert Dev to use Docker. It's on our roadmap, but given that everything works, it's really unlikely we'll get around to it. We also run servers for reporting, spying on users, not really, serving updates, serving images, and all that kind of stuff. And scaling and maintaining all of those servers would become a big issue for us, and we're not a company that wants to scale that kind of thing. Dev also auto-updates, which means that we could run arbitrary code on everyone's machine. You probably don't want that feature. And we also give Dev access to a whole load of internal stuff using SSL certificates and all that kind of thing to give privileged access into our data centers and stuff like that. We need to separate all of that out. The long and the short of it is basically it's a lot of work to open source it, but more importantly, it would add a lot of complexity to our code base, and I don't think it's worth it. That said, it's still an ongoing conversation internally, which is why I brought it up, because I'd like opinions from people afterwards. finally, I just want to sort of summarize the things I learned while building this system that I hope will be useful to you. The more people you have and the more complex your project becomes, the more time you can save by actually fixing people's problems automatically, especially when it comes to less technical users. You can actually measure this crudely by figuring out who needs what help, how long it takes to fix a particular issue, multiplying that by the number of people who are having the issue, and you can actually work out how much time you're going to save by building a proper developer environment, scripted, consistent system for your users. I'll bet you'll save more time than you think. Speed is important to users. Cache everything. Consistent interfaces are really important. They work across all of the languages. I had to work on a new Go project last week, and someone was using a fancy new way of managing Go packages and dependencies. And luckily, I didn't have to learn any of the new magic commands to get everything working. I just used dev up and it handled it for me. And if I did want to learn, I could just look at the dev up entry to figure it out. You need to consider both GUI and command line users, especially with regard to editors. If you have Vim users and Atom or Sublime users in your company, you need to cater for both. I say that. Some companies sort of try and make a happy path and just build an IDE on top of Atom. I think Facebook is doing that. But I would cry if someone tried to take my Vim away from me. And at the same time, I couldn't really inflict that on the entire company. So we have to stick with multiple types of editors. We also, bizarrely, have some people who are still using, I've even forgotten what it is. What's the editor that everyone used to use? TextMate. We still have TextMate users. Who here still uses TextMate? Oh, one person. There's always one person. So it's good to support that as well. But it's not just editors that need help. What we did is we built a little Mac app, simple as anything, that just sits on top of dev, and it allows non-technical users to run any of our projects. It's made things much easier. They don't have to ask people for help. They can just run a project, get a data set into a consistent state, and go and get it running. It's super important to keep people up to date. What we found originally is we would be constantly saying, yes, you just need to update. It's in the next version. It's in the next version to solve people's fixes. So what we do now is we actually check for updates. Well, not on every command prompt, but every 30 minutes when someone types in a dev command. So users are rarely more than 30 minutes behind the last version, which has really helped our fix rates and our toil. I learned this lesson the hard way, but it's important to keep basic installation code separate from your time and bug-specific fixes, and it's important to make sure that you delete that code when its time is up. Lastly, containers provide great isolation between projects, and if you condition people to think that the containers are ephemeral, then you actually get far fewer issues with people running on crappy dev data from 3 months ago that they inserted manually into their database and is now completely wrong. If people wipe out their dev environments every day, then they're never going to have a problem that's more than a day old. This also encourages people to write fixtures and other sort of data creation scripts that are more shareable and the whole company benefits. So that's all I have to say about development environments for now. You can contact me that way. And thanks a lot. Are there any questions?
Dev environment every day. Aren't you effectively wasting so much time rebuilding it?
The question was, if we're wiping our dev environment every day, are we wasting so much time in rebuilding it? No, because realistically, people don't have to get rid of their dev environments every day, but it's fairly often. The other thing is everything is super, super fast. We have a lot of caching from Ruby gems to database images, and so it takes about 30 seconds to wipe out your complete app state and get it back to a pristine state. That's nothing. basically. So yeah, we don't have that problem. There was someone off the back. So what's the rationale behind having a dev environment separate from your production environment? Yeah, that's interesting because we've gone back and forth between trying to make them as close as possible together and then splitting them up again. And fundamentally, they are always going to be different because they're always connecting to different servers for a start. The development versions of databases are different from production versions of databases. They behave differently and they perform differently under load. So there's always going to be those differences. Then there's the matter of scale. If you have 100 servers hitting a Redis, again, that's completely different performance metrics to your development environment, and all of those changes need to be encoded somehow. And whether you like it or not, those changes will be encoded. We just decided to give up and keep it separate and then run a hell of a lot of tests on making sure that those production things worked in the way that we wanted to, instead of using our dev environments to pretend that the production environments were the same. Anyone else? Ubuntu. We use Ubuntu in production, mostly. Several different versions, and I can't remember which ones. Not the current legacy, but the previous long-term support. I think 1404, yeah. Definitely some of our servers are on 1404. I don't remember. Anyone else? No? Great. Oh, sorry, there was one more. Yeah, great question. I thought you were going to ask me whether it's because we were being lazy. The question was, a lot of the reasons I gave for not open sourcing were that we would have to support it. And couldn't we just dump it over the wall and present it to the world and leave it? Partly it's laziness, because we don't want to support it. And the other reason is I don't know if I'm right about this, but I feel bad to dump some code over the wall and some naive person picks it up and goes, yay, open source, it's going to work for me, and then there's nothing, no support. I think that really sucks, and I think, and I'm not convinced of this, I think it's irresponsible, but I could easily be convinced otherwise, I suspect. All right, thanks everyone.